I'm Daniel, and I'm taking you today through a journey of bringing our Python code to the cloud. Let me turn on my camera. Oh, my camera is on, cool. I am a DevOps team leader today at Red Hat. I'm working on OpenShift CNV department. OpenShift is the enterprise offering for Kubernetes at Red Hat. Feel free to add me in LinkedIn, and I'll be very happy to connect with you. And everything that we'll be talking today and all the code will be actually available in my GitHub account. So let's move on. Let's start. What we'll cover today. So we're bringing our Python code to the cloud. And the best way to do it today is through pipelines. Here we'll be using actually a pipeline of pipelines. That means that we'll have 3 different pipelines that they can be used independently, but they actually can be connected together in order to accomplish the mission of bringing the application to the cloud. Okay, so let me go very quickly through the process, and then we can just jump in with some details. Okay, we'll build our application. Okay, it's a Python application. Then we will be executing some tests, and once we have the tests in place, we'll publish our Python package to our registry. Okay, we have tar.gz packages and wheel packages that will be published to our registry. In parallel, we will be able to create a container image for our application. Okay, here we'll go through some best practices to create this container image. And once we have this image, we can push to our private registry. And once we have it in our private registry, so we'll be able to scan this image and find the licenses inside of the packages. And also we can find security vulnerabilities. Okay, in parallel, we'll create a Helm chart. The Helm chart will actually contain all the manifests that will take our container to the cloud, to Kubernetes. Okay, so all the manifests, they are packaged into a Helm chart. We will validate this Helm chart as well, this manifests, to see that everything is according to the best practices. Once we have everything in place, we can publish it to our registry again, and then go ahead and deploy it to a staging environment. Once we have the staging environment in place, we'll run more tests, and then we'll be able to deploy it to production. That's clear? Cool. So let's start with the application. So the application, I started using Flask, and then I thought, why not to maybe to try something a bit different, and then I found Fast API is also a Python framework. I used it for HTTP REST API application. Okay, that will expose a few endpoints like this. Okay, this you see is the documentation that is automatically generated by the framework. Okay, it's a Swagger application, Swagger documentation. There is also a Redoc that is also a very nice interface for documentation. So one of the big advantages of Fast API that I found is using ASGI instead of WSGI. And the main difference here is that everything happens asynchronously, and definitely it's able to provide faster results and better performance. So why not to use it? Also, one nice addition, and it comes out of the box, is Pydantic. for modeling the responses and the way that we put the data to our database, for example. It also validates the data, so it's very nice. It saves us a lot of time in adding all sorts of validations. And as I said, we have the documentation out of the box. So it's a nice framework that I used for this demo. Okay. For the package manager. So when we start dealing with dependencies, and then also at some point we will want to create our Python package and send it to our friends or publish it to the world. So I just found Poetry as a very good one. I hope that some of you guys maybe had the opportunity to use it. So Poetry, as I said, is a package and dependency manager. It makes our lives it makes our lives very easy in boilerplating new projects, for example, and dealing with production and development dependencies. You can handle them and separate. You don't need special mechanisms and special tricks to deal with it. It's already built in the manager, in the package manager. Adding, updating, removing dependencies is very easy. In the process of packaging and publishing, as I said, we will be publishing the package to Artifactory. Artifactory will be our binary manager for this demo. Artifactory by JFrog. Okay, we have also the lock mechanism in place for this one. So it's very easy to keep it safe and have our dependencies well protected. And the virtual environment is already handled out of the box as well. So let's see, I want to share with you here. So let's go ahead and create our first Poetry project. Let's say that we want Poetry to create a new project. So I will create PwC proj. And this is how I create my first Poetry project. It's just a Python project. Inside of it, I can see different files were created for me. So the structure goes like this with a README, my first Python module here, some tests, and the main file here, at least for this stage, will be the pyproject.toml that actually contains all the dependencies, the regular dependencies, the development dependencies, all the different configurations that will be used to bring these dependencies and also to publish them. Let's take a look. Let's see how it looks. So it looks like this, okay? It was created automatically, but let's say that I want to be a bit more specific while creating my first project with Poetry. So let's just maybe remove this one and let's create another one. So I can go to this folder and I could do just Poetry init instead of new. And now I get into a very an interactive way to create my dependencies and to declare them. So let's go ahead and let's call it this way. This will be my first version, I think. No descriptions for now. Let's keep it. And then, okay, now the license will be MIT. I can define the license. I can give a lot of different information for my project to specify which Python is the one that should be used. And now I start to deal with my dependencies. So I have here first my dependencies. Yeah, let's go through it. Search for a package. I would like to start maybe with requests. Let's try requests. And yes, I found this one. Cool. I will just use the latest version. So pressing enter again. I don't want to add a new package. And now I'm handling the development dependencies. Okay. Let's say that I want to add PyTest, and then that's it. So here, this way, I have my poetry file created. And then let's say that once I do poetry install, it will create my log file as well. Now, one more very interesting thing is that I have virtual environment already built in poetry. So for example, if I want to run, if I have a new file that is called, for example, let's say that I have a main.py, and then I have here, and let's say that we want to just get some result from GitHub. And I just want to bring the status, to have the status code, for example. So this is what we do, the magic. And let's say that so when I have this, my first file, okay, my first my first code here, my first piece of code, and then if I want to run it, I can just start right with Python and then main.py, right? But also I can use poetry run, and then it will automatically use my virtual environment according to my dependencies and according to the Python version that I choose, and so on. So this is for poetry. Okay. I had a very good time using this package manager. It was very easy to take also after finishing coding to create a package and just configure Artifactory to be my private registry in order to publish my packages, and it was very smooth, I would say. I really recommend this one. Let's move on and go through the containerizing our application. So for containerizing our application, there are a few things that we need to keep in mind. Okay, so one thing is to keep the images as clean as possible. Okay, I really recommend to use the multi-stage pattern. Okay, multi-stage pattern is where you can use in the same Docker file if you had the chance to use to write your own Docker file. So so you have the opportunity to actually use different stages inside of the same Docker file, even using different base images for different steps, okay? And at the end, you can even copy files from other stages to the last stage. And my final image that will be created from the Docker file will be the last stage that will eventually copy files from other stages. And this way I can keep things simpler and smaller. I get less binaries once I use lighter base images for my Docker files. I get less layers. My container image becomes more portable, and I I get less, eventually less vulnerabilities. Okay, so one more thing that I tried during while I was preparing this demonstration was to use Podman instead of Docker. Today, a lot of people, they are trying to find alternatives for Docker. Also, Kubernetes, if I remember correctly, version 1.20, I think, deprecated Docker as the runtime, moving just to the CRI standard. Yeah, people are more and more looking for different alternatives. There is no doubt that Docker made a big revolution in the industry, but today things are continuing to go on, and the evolution needs to continue. So I used Podman. Podman is the same as Docker, but was created by Red Hat, actually, and it does exactly the same thing, adding a lot of stuff. So I want to show you a little bit about Podman. So the commands with Podman, they are pretty much the same as Docker, okay? So you can even go and make an alias, Docker being Podman. And then when you do Docker PS, you will be actually running Podman PS. And when you use Docker images, I will have these images here. Okay, let's try even to remove some images. I will be using Podman from now, but RMI, let me remove a few images. I will remove this and this and this. Yeah, nice. So again, Podman images, and we are good. So let's say now that we want to create our Docker file, and right, we want to use the multi-stage pattern. Let's go there, and instead of using a Docker file, let's make it a bit more generic. Let's call it a container file. So let me remove the previous one, and let's create our own container file. So here is my container file. I can, the same way as I create Docker files, I can go and from Python 3.10, I just want to set a work dir as file, and then just run a command that will actually bring this string. This is my first file into the first file. Cool. And that's it. This will be my first stage and my first, let's call it a Docker image, but let's call it a container image. Yeah. Cool. So I can go and just like I do with Docker, I can do Podman build -t. This will be my fat image. And I will give this context here. I see that everything worked, all the steps. It created this image here. And this is the hash for the image, the digest. So let's see how. Oh, it's almost 1 GB image. I didn't do nothing, okay? I just used Python 3.10 and I got almost 1 GB image. So, okay, let's try to move a bit further and actually create another stage. So let's call this one as builder, right? And I want to create another stage that we'll use instead of just Python 3.10. Let's try to make it a bit slimmer and another builder. It doesn't matter how I call it. I will also set a work dir here. So my work dir will be, let's say, source. And let's say that I just want to run echo right, and I want to create my main.py file, and that's it. So this will be the same image, okay, and then it will go through the first step, and then it will go to the second step, okay. Let's see how it happens. But now I don't want to call it fat anymore. I want to create it slim. And now I see that the first part was executed, and then the second one. And now let's see. Now I have the fat one that is almost 1 GB, and I managed to shrink it a lot. And now I have the same Python.10, but slim, and now I have 122 megabytes. So yeah, we are getting better, but I think we can get even better. So let's try to create one more step or one more stage that will actually use Python the same, 3.10, but this time I want to use Alpine. And then with Alpine, I want also to have my work dir as all. And what I'm going to do, I'm going to use the files that I created in the previous stages. So let's say that I want to copy from builder, right? And I want to go to the directory that is called file and take my first file, right? Let's take also from the second one. So I want to copy from the second one will be another builder, right? So this will be source, and then I have the main.py. And now I have a third stage that is this one that will actually copy from here this file and from here this file, okay? And at the end, let's say that we want just to serve these files, and I will just, in order to see it, I want to use the HTTP server module and just add this port here, 888. Cool. And now let's try to build it. Again, now I have the slim, and now I have the slimmer, even slimmer image. Let's see how it goes. Okay. So it looks like we forgot to add here main.py, and also here my first file here, and that's it. It will be relative to this working directory. So let's go there and build again. And then source main, and then cool. And now I can see that my image got 50 megabytes instead of 122. And I'm still using the same Python 3.10. So there are a few ways to make the image smaller and smaller. And again, once we have smaller images, we have less binaries, less layers, more portable images, less vulnerabilities. Okay, and how do we run actually this container? So we go and we have this image. Let's take the slimmer one, and we can run in the background. So let's expose the port 888 to port 888, and let's give an environment variable, for example, for staging, and let's give it a name. Let's call it a server, my server. Cool. And then let's give the image. Cool. Now I see that I have my running container here. Just like I do with Docker, I executed this image, okay, and then created a container out of this image with this name here. This is the command. And you see that it lists in the directory with my main.py file. Okay, so now one more thing that Podman helps us is to go even closer to Kubernetes. And it actually brings us not only to containers, but also to the pod concept, okay, that is used in Kubernetes. So, for example, let's say that I want from this container here, I want to create a pod definition, a pod manifest. So I have this container here, and then I can Podman. I have a whole, let's call it a namespace related to pods. You can see here, I can do a lot of stuff that are related to pods inside of Podman itself. Okay, and then let's say that we want to even generate, I can generate a cube-like pod out of my, out of my server container. So what I'm doing here, I'm using Podman to generate a cube-like manifest to my container. And this should generate my manifest for the pod with all the information that the container has. So it will be just translated to this YAML file here. Okay, I can even save it to my pod.yaml, let's say. And one more thing that Podman helps us is even if we want, okay, we now did Podman generate, right? Cube and the name of the container. So now I want to just play also like Kubernetes, simulating Kubernetes, and I can run my pod inside of Podman. The port is already binded because it's already being used. So let's remove this container here, and just like with Docker, we remove the container. And now my pod is already there. Podman, pod ps, and I see that my pod was created. So this is how Podman can not only be an alternative to Docker, but it can take us even further to the pods and Kubernetes and cloud world. So that's it for Podman, and let's move on. Cool. So now we have our application. We already took care of the dependencies. We packaged our dependency already, and now we already created our container. And now we want to actually create our Helm chart. Okay. So how Helm can help us here? So Helm I just showed you the how the pod manifest was created. So together with this manifest, we will have a lot of different manifests eventually, and we need a way to put them together and to make them even dynamic. Okay, the content of these manifests. So Helm comes to make easy to find and share our application together with its dependencies, okay, and make all these manifests available as a package. You can even give it a version, not only to the application, but also to the Helm chart itself. So you create the chart, you give it a version, you can share it, you can publish it everywhere. Okay, you can see down here how does it looks Helm chart after adding the different values that were taken from another file. So the values here that they were created dynamically. Cool, and I will show in 1 minute. But I just want to mention also about the release lifecycle. So with Helm, it's much easier to not only to release, okay, to create new versions, to release, and then to roll your application through Kubernetes, and even to have a revision for each one of the actions. You can manage the dependencies this way inside of the chart. You can have the history for the releases as well. And I want to show you actually how it goes, okay? Let's see how Helm works and what is the anatomy of a Helm chart actually. So let's say that we want to go to our PwC project. And now we want to create our first chart, okay? And let's go and do Helm new, and I will create a chart. It's not Helm new, it's Helm create, sorry. And now I just created my first chart, and that's it. Let's see how it looks. I have here now this folder that is called chart. And from this folder, I can actually see these files that were automatically generated for me. So let's see, what do we have here? We have the charts, the chart.yaml that will contain the general information about the chart, including its version and dependencies and descriptions and license and everything. Okay, we have the charts folder where all the dependencies will be stored. I can store all my dependencies here. And we have the templates. So the templates is where the magic happens, I would say, because all the values that we have here in this YAML, they will populate all of these manifests, okay? You can handle some logic with the TPL file, with the template file. And let's take a look at this deployment, for example, okay? So we go to chart, and let's take a look at the deployment, templates and deployment. So you see that the deployment, it's actually like any regular Kubernetes manifest. In this case is deployment, okay? And it includes a lot of different variables. These variables, they are here using the Go template engine, okay? Because Helm is written in Go, so it's very natural to have Go template engine here to get these results from the values file. So I have here all the definitions that I need, okay? It can come from different objects, for example, the chart object itself. It can come from the values file. So all the content of my manifests, they become very, very dynamic, okay? And if I just want to see what will come out of this template here, okay? Even for troubleshooting or just to see how it works. So let's do Helm template and chart, okay? I can template this chart, and now all the manifests, it will show me all the manifests that will be actually used for creating my deployment, for creating my application. Okay, now I have the deployment, and now instead of having all kinds of variables, we'll have all the values here. Okay, and the values, they are coming from the chart object, but also from the values file. Let's take a look at the values file. And it's just a YAML file with different parameters and different variables, and everything can be taken outside. And you can, of course, you can use the same Helm chart with different values file. Okay, and that's where the values become totally dynamic. Okay, for each environment you can use different values, for example. So this is Helm. It's very easy to create the first Helm chart. It works out of the box. And again, very, very easy to manage also releases. So by default, it will use the rolling update strategy, but it depends on what you choose. But in general, you will roll a new version of your application, and until the new pod, it's not until it's not able to get traffic and connections, the previous one will not go down. So only once the application is ready, the previous pods will be taken down. This is for the rolling update strategy. You have other strategies as well, of course, with the blue, green, and other different mechanisms. So this is for Helm. Okay. Now, how do we put everything together? Now, okay, we have the containers and we have the charts and the packages and everything. And now we want to make everything go to the cloud. I mean, everything should happen in an automatic way, and everything should go to the cloud. But we need to take into account that if we want to add a piece of code and have this code into production automatically, we need to keep in mind how important are the tests and check everything before we put anything into production. Okay, so here we need to take into account all the security part, of course, the compliance, if my company allows this kind or that kind of licenses into my third-party libraries. I need to run all the relevant tests, all of them, unit, front-end, back-end, benchmarks, everything should be part of the pipeline, okay? And one important thing is to keep staging as close to production as possible. So you can be very, very sure that you have what happens in staging will probably and definitely will work very well in production. Okay. Also misconfigurations. Okay, during this manifests generation and everything, a lot of different misconfigurations can happen. Okay. So today there are also different tools that can go through the manifests and just find things that they are not really according to the best practices. Use these tools. Use as many tools as you can to make sure that the code that you put to production works well. Okay. Cool. So here, for example, we see where we use different labels just for staging and production. Everything happens just like the same, but you use different labels. This can happen. In my example here, I'm using two different clusters, actually, one for staging and another for production, and using just different labels. There are some different approaches of putting them in the same cluster. Personally, I tend to not go to this approach. I prefer to have production and staging in different clusters. So if anything bad happens on staging, it will not affect production. But there are different approaches with just handling it with affinities, tolerance, and taints and this stuff. But it's not in the scope of this talk. So how do I put all of it together? Okay, there are many different technologies and things happening, and I need something that I will actually be able to put them together and organize my pipeline. So I have here the platform, the JFrog platform that I used for my demonstration. Okay, and here I am using JFrog pipelines, okay, to organize everything. Remember, it's a pipeline of pipelines. So I have different pipelines that they are actually used together. They can be executed totally independently, but they are also being executed together in order to accomplish the mission of bringing the code to the cloud. I'm using Artifactory. Artifactory, it's actually serving as my main packages hub, because when I bring third-party libraries to build my Python package, all these libraries, they stay in Artifactory. My package at the end of the day, once I build it, goes to Artifactory, okay? And then when I create my container image, I push it to Artifactory. The Helm chart is the same for the Helm chart. So everything is kept in my Artifactory instance, and this way I keep myself totally safe and totally sure that even tomorrow, if the internet is down, so I still have my dependencies with me, I still can build my project, I still can even deliver my software. Okay, so this everything happens in an Artifactory, and then with X-Ray, actually it's a very good way to keep all these binaries, actually, to keep all of them safe, meaning that everything that I have in Artifactory, my first-party software, my third-party software, my images, everything is continuously being scanned and continuously bringing me information about licenses and vulnerabilities. Okay, so let's see how the JFrog platform actually helped me here with it. Let me log in. And I am here. This is a JFrog platform. I have here my packages. Okay, so how did I configure everything to work with the different integrations that I'm using? One reason to use JFrog pipelines is that as Python, JFrog pipelines has a lot of, all the batteries included, I would say. So dealing with the Python packages and images and Helm and publishing and packaging and deploying, everything happens in very, very familiar steps into the pipelines. And they are very easy to use, I would say. I will show you in the next few minutes. So let's move on and see how actually I configure the JFrog platform. And here we have Artifactory, okay, that is holding all my packages. I also configure the X-Ray. X-Ray, in X-Ray I created a policy that actually takes and give me feedback about critical security vulnerabilities. Okay, so it will keep an eye on all the vulnerabilities that they have severity critical. And for using this policy, I actually create a watch. Okay, and this watch will actually will tell which resource I want to watch and which policy will be applied to each resource. In this case, is a repository. It can be a repository, it can be a build, it doesn't matter. But here I see that I have my builds here configured, and they are using this policy here. Okay, and this is how I configure the X-ray. I also selected resources for indexing. So all these repositories here, they are being continuously scanned by X-ray. I have here my Docker repository. I have my Python repository as well. I have my builds. And here in Artifactory, I actually created different repositories for different purposes. As I said, I have my Docker images. Here I have all my Python, my PyPy-like modules, and also my chart, my Helm chart packages. Everything stays here with me, okay? Everything that I bring from outside and everything that I create myself, everything stays here. So let's go to the pipelines. This is for X-ray, and for the pipelines, I created these integrations here. Okay, so I, of course, have Artifactory integration where everything, all my binaries are handled. I have my Git repository, that is the one that I shared with you guys, is this one. And I have my staging Kubernetes cluster, okay? And I have my production grade OpenShift cluster as well, where I will, which I will use for production. And let's see how this pipeline actually is built. Let's go there and see how it's built. Cool. So I have here the, I have the packaging part here, and I can share with you what is happening in this first part here. So as I said, it's a pipeline of pipelines, and you can see here these 3 steps. In the first one, I package my application. In this one, I create the image, and here I deploy to production. Okay. So in the first one, here I will just build my application. And then I will execute different tests. Let me make it a bit bigger. I will run different tests. Okay, I run them in parallel. And then I publish my app, okay, to Artifactory. All the code is here. Okay, we can see that the pipeline code is, it's a YAML file, okay, that contains all the different steps. So handling a Helm chart, here it's like just like this, and then we have upload artifacts just like this, and Docker build, Docker push, everything is here. Very easy to do. And now the next step, let's jump to the next step here. So if I go to the image part, this is another pipeline that will create the image, will publish that, will push the image to Artifactory, validate the Helm chart for me, okay? And then it will publish the Helm chart, run the security and compliance. And then I have the last one, the last step, that will actually be deploying my application. So I go to the pipeline, and then I see that I have my staging deployed, and then I run a few more tests, kind of benchmark and integration tests and other important tests, and then I am able to deploy to production.